Example 7. How to use geometry to save time in integrals. Recall example 4. So in example 4, we looked at the area between the x-axis and a curve where the lower limit of integration was a different function. So recall that this was y is equal to the square root of x, and this was y equals x minus 2. So we can find the integral of 0 to 4 of the square root of x dx, which would be everything under the curve, and then simply just subtract off the piece we don't want. So what I mean is, if we integrate and get all of this area underneath, and then subtract off this triangle. And so essentially that's going to give us the area we want, which is this area in here. So to do that, let's first find the dimensions of the triangle, where this is going to be 2, and this will be 2. So then our total area is going to be the integral from 0 to 4 of x to the 1/2 dx. And I'm going to take all of that and I'm going to subtract off the area of the triangle piece. So this is going to become 2/3 x to the 3/2 from 0 to 4 minus 2. Which is going to give us 10/3 units squared, just like we got previously in example 4 and in example 5. So now on your own, I want you to try to determine the area enclosed by y squared equals x plus 3 and y equals 2x and the x-axis using geometry, using the method we just used. Alright, so here we go. So the area we don't want is from this triangle in here. So then what we're going to do is find the area of everything under this curve and then subtract off this triangle. So this becomes the integral from -3 to 1 of the square root x plus 3 dx subtracted by 1/2, and we need to use the dimensions of this triangle, which is a 1 by 2 triangle. So times 1 times 2, and this is going to become the integral from -3 to 1 of x plus 3 to the 1/2 minus 1. And to integrate this, you're going to use a u sub, and you'll end up getting which is going to be equal to 4.333 units squared.